Question 8a. In November 1923, 18 koalas were introduced on Kangaroo Island. By November 1993, the number of koalas had increased to 5,000. Assume that the number n of koalas is increasing exponentially and satisfies an equation of the form n equals n naught times e to the power of kt, where n naught and k are constants and t is measured in years from November 1923. Find the values of n naught and k and predict the number of koalas that will be present on Kangaroo Island in November 2001. The first step is to find n naught. So the initial population is 18 koalas. Hence, n equals 18 at time t equals 0. Substituting 18 for n and 0 for t into the formula n equals n naught times e to the power of kt, we have 18 equals n naught times e to the power of k times 0. Now note that e to the power of 0 is equal to 1. So 18 equals n naught times 1, therefore n naught equals 18, and n naught represents the initial population of koalas. The next step is to find the value of k. Now in 1993, n equals 5,000. Now to find the value of t that corresponds to 1993, t is equal to 1993 minus 1923, which gives a value of t of 70, which represents 70 years after the year 1923. So substituting t equals 70 into the equation, knowing n naught now, so we've figured out that n naught is 18, and the population 70 years after 1923 is 5,000, we have 5,000 equals 18 times e to the power of k times 70. Now solving this equation for k, we divide both sides of the equation by 18, and we get 277 and 7/9 is equal to e to the power of 70k. Taking the natural logarithm of both sides, or log base e of both sides, we get ln of 277 and 7/9 is equal to 70k. And then dividing both sides of the equation by 70, we get k is equal to 1 over 70 times ln of 277 and 7/9, or in decimal, it's equal to 0.08038316334. Now it's important not to round this value of k at this point. Now the value of t that corresponds to the year 2001 is given by 2001 minus 1923, which is 78. So substituting t equals 78 into the formula, we get n of 78, which represents the population of koalas in the year 2001, is equal to 18 times e to the power of k times 78, which equals 18 times e to the power of 0.08038316334 times 78, which equals 9,511.515, and so on. So rounding this value to the nearest whole number, we get around 9,512 koalas are predicted to be on Kangaroo Island in the year 2001.